Kia ora ana tātou katoa, I te ara, te tūrau atu nei au I a koutou ki te akari arianga a te runanga te kere moana. Nā runga I tā mātou kaweinga waitoanga ki te aorangi. Tōku ingoa ko Rima Brown, no roto mai au I te runanga te kere moana o te Kuki Airani. Greetings and welcome to this presentation on the Cook Islands Seabed Minerals Strategic Environmental Assessment. My name is Rima Brown. Today, we're going to talk about 4 key things. First, a short background presentation on our Ecosystem-Based Management Framework, or EBMF, what it is and why it matters. Then, we'll talk through the 4 sub-studies that make up our Strategic Environmental Assessment. This slide summarizes the results from each of the first 3 sub-studies. You don't have to pay too much attention right now, as we will come back to this slide at the end. But basically, the results have been quite positive and encouraging, and this presentation will take you through how we got these results. And now I'm going to pass it on to John to continue with the presentation.
This has been a product of quite a bit of work over the last few years, and the main partners in this work have SBMA, or Seabed Minerals Authority, has led, followed by NES, or National Environmental Service, as our partner. Then we've been using consultants. We use a consultant called BMT. BMT are an international maritime and environment consultancy, and specifically the experts, a thing called environmental impact assessment, which is an important part of what we're going to talk about today. We've also used a second consulting firm called Orca Consulting. They do a lot of ocean management type work, and one of their specialities is stakeholder engagement, and we've used them to try and make sure that this consultation step of what we're doing is done as well as is possible. When we did the work, the technical side of the work, an important part of science is getting unbiased, independent scientific review from your peers. So these logos here are subject matter experts that were consulted throughout the process at different times for different people. And these are the people who we have a great debt of thanks for, because they helped us understand some of the issues that we were dealing with and allowed us to do more accurate assessment. We also did ad hoc consultations, and this was to a broader base. And these are some of the organisations here that you can see, some well-known ones from the United States, for example. And it included 2 conferences. The first one is the Underwater Minerals Conference, which was held in Rarotonga last year, in 2024, as well as one hosted by the IRD, the French IRD, in Tahiti the same year. There's a lot of information that's gone into this study, and it's really impossible to go through it all in detail. So what we've done is to try and keep it simple, but give people access to the detail as they need it. We built this thing called an information pyramid. If you go to the website listed here, and if you have a specific question, you can dive down through the pyramid. So all the key technical reports and their annexes, as well as high-level or more technical presentations and some high-level presentations, are all available for you to look through. Of course, you can just reach out to us too with any questions. The process for the Strategic Environment Assessment actually commenced back in the first quarter of 2022, and the final technical study was only finished in the first quarter of 2025. So you can see it's been a few years to get through all the work. The way we started was we looked at what was done in other jurisdictions. Then once we understood the way forward, we went and did technical studies. Now we're at the midpoint where we're consulting with people, and we're going to ask you to do a survey on what you think we've done. Then we're going to go to a workshop, a public workshop later in this year. And out of that workshop, we want to get some recommendations for government policy for the seabed minerals sector. In a few years' time, we expect we're going to have a lot more information. That might be a good time for us to review and update this study then. The first section we're going to talk about is the ecosystem-based management framework. An ecosystem-based management framework is a framework with all the different components that go into environmental management. It can be really confusing because there's a lot of different terms, a lot of different jargon for different types of studies and databases and so forth. So what the framework does is it pulls it all together onto one page so people can see where a particular study fits and what it's used for. But it goes beyond that. What it does is it also tells you when a study needs independent peer review and when a study needs public review. And it also tells you when a study includes a thing called an environmental impact assessment. That's a really important step because we use environmental impact assessments to make decisions. Here's a diagram of our seabed minerals environmental-based management framework, ecosystem-based management framework. So we've got here some central components, some principles. These are like the laws and the other principles that we sign up to when we think about the environment. It includes, for example, the precautionary approach. Underneath that, we've got our baseline data. This is in the Cook Islands, all environmental data goes in the public domain, and thus it's a central component that is used by everybody in this space. Ultimately, there's a permitting process and a permitting decision that needs to be made. That needs to be as transparent and as inclusive as possible. On the left and right, we have two more pillars, if you like. Today's discussion is focusing very much on this blue pillar. This is about a regional review or a regional study on the impacts of potential development. Today, no development's allowed, but it doesn't hurt to try and look into the future and try and understand what might be coming. On the right-hand side, this is your fundamental environmental impact assessment, environmental impact statement process that's required for any industrial development, including seabed minerals development. If you're building a bridge or something like that, you're required to go to the National Environment Service and get an environmental impact assessment signed off. You can use the analogy of a bicycle to explain how all this works. The back wheel is like the EIA. It's the driving force behind a bicycle. The front wheel is like the SEA, or this side of the framework. It kind of tells you which way the bicycle is going to go. The frame is the knowledge that links everything together, but most importantly, the rider is like the stakeholders, like you, and the principles, because that's what steers the bicycle in the direction it's supposed to go. This is the same thing again, but in a little bit more detail. You can see there's a lot of different assessments, exercises, statements, and plans that are required to pull this EBMF together. And these are the goals of our EBMF. This diagram also shows you if public consultation is required, the study concerned or the plant concerned is in purple. If peer review is done before it becomes publicly available, like for these three assessments, then it's in orange. If there's a little asterisk next to the word, like we have here and here, it means there's been an impact assessment included in there.
Kia ora, my name is Rima Brown, and I'm going to be taking you through one of the first SEA sub-studies, and that is the Marine Spatial Assessment, or the MSA. The MSA tells us about the different types of habitat that we have here on the Cook Islands seabed. And on the screen here, we have different types of habitat types. The example we have here is a rocky reef and a sandy lagoon. And what's key to note is that with different habitat types, you encounter different environments and distinct species. So an understanding of habitat types is important and needed for environmental permitting. Now, what we've developed here in the Cook Islands for the deep sea are habitat management zones. And we use two key data sets as surrogates. So the first being seabed geomorphology, which are the types of sea forms on the seabed. And the second is net carbon export to the seabed, which basically means how much food makes it down there. With the seabed geomorphology, we use three types of landforms, and you can see the examples here on the screen. The first is abyssal plains, and you can see examples of long ribbony hills here with the occasional knoll. And these are just examples that you can see on Google Earth when you roam around. The second type is seamount chains, and we have a chain of islands here. This is Aitutaki, Ngāputoru, and you can see Rarotonga and Mangaia down here as well. And the last type of landform that you'll find is the Manihiki Plateau. And as you can see in the picture here, the plateau is flat and raised off of the seabed about 2 kilometers. And just with the abyssal plains, in the Cook Islands, these are at a depth of 4,000 to 5,000 meters. So you can see between different landform types that there is a range of depths, which means the environments are changing between each of these types of landforms. And what we have here on the side are some photos that support this model. So here are 2 transects that were conducted at 7 South, and as you can see with the limited photos that we have with just the sediment, you can see that there's lots of traces of life with the burrows through the sediment. And then as you come further south to 10 South, there's fewer traces of life, less burrows, less tracks. And then even when you come down further to 16 South, you can see barely any traces of life here. And we see the same with the nodules. In the north, the shape of the nodules are oval and more rough, whereas when you come further down to the south, we're finding more smooth and rounder nodules. So essentially what you get is a 3x3 matrix, 3 types of landforms, and 3 types of net carbon export to the seabed, and we get what we call the habitat management zones, or the HMZs. And where you get the lighter shades of color, these are the abyssal plains, and when you move from gray to blue to green, you're increasing in the amount of food that makes it to the seabed. And where you get the darker shades, these are the seamounts, and of course where the mid shades you find here in the north, that is the Manihiki Plateau. So what we're doing is a hierarchical approach, and the habitat management zones, which were done for the whole country, is at the level 1. Now this is okay for the regional SCA. However, once we move onto the permitting side, a lot more information and work needs to be done, as you can see here on the screen. And first of all, this type of work that needs to be done would involve offshore exploration. So the habitat management zones can be used to guide policy. However, they wouldn't be suitable for permitting projects. Now, the most important thing about a marine spatial assessment is that it is hopefully useful. And one way it can be useful is in addressing policy questions. And we have 2 examples. Now, the first is how much of each seabed habitat management zone has been permitted. Now, down here on the left, we have a legend which corresponds to our HMZs. So you have your 3 geoforms and then your 3 net export carbons to the seabed. And basically what we do is these red boxes or polygons are license areas within the Cook Islands EEZ, and we basically calculate how much of these polygons take up in each of the different shaded areas, or HMZs, which is what you have here. And then what we can do from there is calculate how much percentage of each total HMZ has been permitted. And as you can see, the light gray, which is 27%, so 1A, where you have your abyssal plains and very low export of carbon, is where a lot of the license areas are focused. And you can see the same with the other areas, that a lot of the licensing is focused on the abyssal plains. Now, this is great because a lot of work is going to be happening in these areas, but one of the implications of this is we also need to promote research in other areas so that we're not only learning about the licensed areas, but the entire country. Now, our second example is related to Target 3, which falls under the Global Biodiversity Framework, which is an international agreement that the Cook Islands have signed to. And basically it aims for the protection and conservation of 30% of land, waters, and sea by 2030. So what we've done here is exactly the same as with the first example, and now we've taken the Marae Moana protected areas, which are the red circles here around each island. And what we've done again is some calculations. And as you can read here on the screen, where we have 1B and 2B, so our seamaps and islands, you can already see that they're meeting those targets. However, when we look at the abyssal plains, so 1A, 2A, and 3A, we can see that they're much lower. And we need to do some work to hopefully meet the targets that have been set. And so an implication of that, with our license holders doing all this work in these areas, so the abyssal plains, 1A, is that additional effective conservation measures should be put in place so that these HMZs are also represented.
Moving on to the second program of the SEA, which is called the effects assessment. The effects assessment looks at what impacts could be from minerals harvesting or mining. The effects assessment builds on the marine spatial assessment, and when we look at the impacts, we're looking at the context of the habitat. Now, when this project began, we didn't just look at nodules. There are 3 types of minerals prospected here in the Cook Islands. That's nodules, crusts, and muds. The idea of an SEA is to do it before the activity begins, and in a broader scale, it should be done before any kind of development starts. Traditionally, this is not the case. The SEA has only been around for a couple of years. An example that I can bring to mind is the United Kingdom have done SEAs for their offshore sectors. Now we have an opportunity here to do everything that we can see today. And that's all we know about, but all of these things have been studied. And these, what you see before you, these are just patterned diagrams that show some things in common. They usually show that there is a vessel at the surface and there is a harvesting or mining machine at the bottom of the seafloor. Now this collects the material from the seabed and transports it to the surface. When looking at the effects, it's quite similar to the vessel, the lift system, as well as the machinery. When BMT started the effects assessment with the support of SBMA, of course, it was important that it was well structured. Otherwise, it would be hard to be accurate. And 2 things to consider. The first thing was to separate cause versus effect, and secondly, is the severity of an impact versus the extent. Now, we're used to using this analogy of cutting down trees, and obviously deep sea mining is nothing like cutting down trees, but everyone really knows what's involved when doing it. Cutting down a tree is not an impact, but a cause or a pressure. The impact or effects is that you lose the tree or you make noise. Now, severity versus extent. Severity is like if you cut down a tree, you lose the tree. So the severity is I have no tree, I end up with no tree. Now you lose the ecosystem services that come with that tree. For an example, the birds may not nest there anymore. It provides some sort of shade or other sorts of organisms or animals cannot use this tree for their own purposes. And when you consider severity, you have to also consider if there is recovery. Cutting down a tree, if it grows back quickly, compared to cutting down an old tree where it might take decades to grow back or maybe not even grow back at all. Now the extent is different. Do we just cut down one tree, or do we cut down the whole forest, or do we cut down 10% of that forest? So that's the severity versus the extent. Now this all sits within the internationally accepted methods and standards to which we follow, and a lot of people have done this as well. Now in doing this structured assessment, we did it with a framework called DIPSA. This is something that is used around the world today. Now DIPSA stands for D, the driver, which is the reason that you do something. P for pressure, cutting down the trees, and we have a list of pressures here for seabed minerals. S for state, which is the state of the environment. It gives us a fair idea of what type of habitat we're working with. And of course, the impacts and the effects, and leading lastly to our responses, how we can find better ways to mitigate or manage this activity. This is where you do the assessment for severity, extent, and significance. You have a chance to look at the responses and really look at the way that you did things. Maybe there are things that you could have done better. And a good example of this is the water depth at which you return what's left over. So for an example, the material that was collected from the bottom of the seabed and lifted up in the lifting system to the surface where the nodules are removed, and what you have left needs to be returned. But at what depth do you do that? And when you start looking at the effects assessment itself, you go through a 4-step process. Now the first one is you read what you know, and this will tell you how confident you can be. And it's important for people using this assessment to see how confident the people doing the assessment was. Secondly, we assess the severity of how severe taking substrate from the seabed might be, and etc. Thirdly, we look at the extent. In this case, we are looking at the habitat management zones. And last but not least, you combine severity and extent into significance. Now, remembering that in each step against severity and significance, you assign a confidence rate. Significance is very important because it is what decision makers will use to decide on things, if an impact is acceptable or unacceptable. Looking at confidence, we use the scale that is found in the Seabed Minerals Authority Guideline 17, which you can find on our website. And this is based on something we got from the International Seabed Authority. Low confidence is where no one can agree, and high confidence is when we have this thing called scientific consensus, along with some other things to consider. Now from there, we go and work out the severity using a series of matrices. The extent really is the percentage number for the habitat management zones. And here are some of the examples of severity and extent which might be assessed differently. For example, log cutting and seabed minerals.
In the previous slide, Tanga introduced the severity versus extent matrix. Now, this slide shows a table that will be used by experts when making their assessments on the severity of impacts. They will base their assessments on the impact on key species or protected species in that habitat or HMZ. Most importantly, they will assess the change in ecosystem function. This part of the assessment is based on a comprehensive literature review of development concepts. We, or I should say BMT, looked at a wide range of possible environmental pressures from the surface right down to the seabed. Also should say that alternatives were included or considered at each stage of operations. So for example, the lift systems. Now pressures were also grouped by depth zones. So you have your near surface, your midwater, and your seabed impacts. These insights were also supported by pilot mining trials and equipment tests, or associated disturber tests. And the same process was repeated for crusts and muds as well.
When BNT did the assessment, it looked something like this, a massive table. And it starts off with the driver, states, impacts. And these are all listed, ending off with some example scores that they will give you either from negligible to minor, moderate, and so forth. To make it a bit easier, you can place the results on a chart, which you can see here. You have your severity on one axis and the extent on the other axis. Something to keep in mind is that the shade in the background is the significance. Everywhere you see a blue dot, that is the effects from a particular pressure. Now, assessing this, they found out that it was moderate to severe and the extent is minor. Finally, we end up with the significance from negligible to minor. Now, what's important is the color of the labels, which tells us how confident we are. Green is well understood, and everything else in orange gives us low confidence, which begs the difference. We need more testing, we need more research, and this diagram tells us that for a single operation is that there is nothing really to be concerned about. Now, we also did this for Tier 2 activities, single operation for crusts and muds, and these are less extensive because the footprint is smaller, but the severity may be slightly higher because in these cases you are actually digging into the mud or the crust itself. Now what you see before you are the conclusions of the effects assessment, and this supports what we're doing. Now we can't start any minerals harvesting. From what we can see is that we have a long way from understanding enough. And there is a big limitation that is, it doesn't consider other multiple industries. Now this will be explained, of course, in the next study that is to come.
Well, it's good to be back, and we're going to take a short break now. It's a good chance for you to get yourself a cup of coffee or have a bit of a rest, and we'll resume straight away when you're ready. But we'll leave you with a question. This is from one of the newspaper articles that we put out last year, where we did an estimate of how many nodules there are in the Cook Islands. Do you want to think about how many there could be? Okay, I'll tell you the answer. If you haven't paused, you're going to get the answer now. And the answer is 702,822,687,631,522, give or take a bit. And we're going to explain now in the next section one of the processes we used to come up with this estimate. It's a thing called probabilistic estimation. This is going to be the final technical section on a thing called a cumulative impact assessment. So, as the fellow on the left is saying, the effects assessment is giving us a lot of encouragement about the severity and extent of impacts from seabed minerals activities. But it's not just about that, because there could be multiple activities, there could be multiple operations. So the other thing, of course, is we need to consider how would those impacts accumulate on top of things like fishing, transporting cargo vessels, and of course climate change. There is a process to do this. It's called cumulative impact assessment, and it is quite a complicated process because there's a lot of things we don't really know about. We need to look into the future as well. But the thing is, the outcome looks pretty straightforward. One thing to get clear at the outset are what the goals of a particular cumulative impact assessment. For this one, for the seabed minerals, we ended up with 3. The first one is what would happen if you cumulated the number of operations, of how big they were. The second one, what would be the effects of these operations on top of an environment that's already being impacted by things like climate change, fishing, and of course the noise from transiting cargo vessels. The last one, which might be of particular interest to a lot of people watching this, is how might seabed minerals activities interfere with things like fishing and other marine uses. When we did the cumulative impact assessment, of course, we went and looked at all the different marine use sectors. So you can see them all in front of you. They're grouped into seabed minerals, fishing. There's a group of other things, including transiting cargo vessels, tourism, etc. And then we've got climate change. The shape of these polygons is really important. If it's an oval like this, this is what we identify to be a principal driver, which is something that overlaps on top of something else. Those were likely to accumulate in some manner. If it's more like a rectangle, what the team found is they're only likely to indirectly interface, if interface at all. So for those, we just did a qualitative assessment where we just went through a bit of a checklist to make sure we'd covered them off properly. Climate change gets its own symbol because climate change was used as a filter over the top of the others. On the slide here, what we're looking at is a simplified methodology for the cumulative impact assessment. It's a little bit more complicated than shown here. If you want to know more about that, I'd recommend you go and look at the technical report. So dive down that pyramid we talked about earlier, and it's on the website, and it's got several diagrams showing exactly how this process was put together. But what we do is we start with compiling information and scoping the cumulative impact assessment, and this was an iterative process. As we learned more about the information available, we were able to better understand what could be realistically scoped or not scoped. Then out of this scoping, we got two particular outcomes. The first one is the interactions between the different types of marine users, and the second one is the cumulative impact itself. The cumulative impact assessment was based on the DIPSA process that we showed you before in the effects assessment. What we did is we were able to build DIPSAs for the different marine users and basically put them together. We went through a technical subject matter expert consultation phase, and during that we learned a lot, which of course gave us this feedback loop. And then the reporting was done a couple of months ago. The governance section here, this is for the future really. This is all about how we update it in the future and how we use it, of course, in policy going forward. These particular two diagrams are just two of many diagrams in the report, but what they try and do is give you some information about the kinds of outputs that the cumulative impact assessment provided. The first one is on exposure, and the second one here is on footprint. So exposure talks about the kinds of pressures that could accumulate together, things like noise, for example. And so what this chart shows is the amount of activity that might develop over time. So you can see these years here on the x-axis are looking into the future. And what these lines represent are ramp-ups of different activities like polymetallic nodules harvesting or crust or mud mining. These two mining-related ramp-ups, as we call them, are shown on this particular y-axis. And this particular axis is showing exposure as a function of area. So it's just hours of operation for a given block of space, in this case 500 square kilometres in a year. This other axis here is for the other non-mining related activities like cargo vessels and the long-line fishing, and to a much lesser extent here, fishing. So the reason the numbers are much bigger here for the mining side of things is the ships don't go very fast. They would stay more or less move slowly on position while they're doing their activities. But of course, cargo vessels and fishing vessels are moving all the time, either trying to get from port to port or chasing some fish. The second chart here, this is the final outcome of all the different ramp-ups for the nodules, the crusts and the muds, and it gives you the footprint basically if you combined all these together. Now, each of these lines here on the left is not a single line. This is the average of a range of possibilities that were looked at. And that's called probabilistic estimation, where you look at a low case, a high case, and something in the middle, and then you can model it as a distribution. And this is what this is. This is a distribution of different probabilities of different sizes, the probability of different sizes, and the total in this area should be all the possibilities. And if we combine all of the different possible scales of nodules and crusts and muds over a 30-year period, then this is the sizes it could end up being. And if you focus on the blue area, this is what we call 80% of the likelihood, or 80% of the probability. Of course, it does assume extraction is approved to start, which hasn't happened yet, but if it did happen like that, we could expect between 30 and 150,000 square kilometres would be either harvested or mined over the next 30 years. That's 80% of the probability. There's a small chance it could be less and a small chance it could be more, but this is the bulk of what we could expect. And because of this uncertainty, this is what makes the cumulative impact assessment process a little bit complicated. Then you can take this chart I showed you before for the footprint, and you can do a little bit of reality checking, and that's what this is doing. You can have the green line here, which is the low case, which is around 30,000 square kilometres over 30 years. You've got the average of around 90,000 square kilometres, and you've got the high around 150. And you can make, for example, on this chart, on the right-hand side, 3 boxes that relate to that amount of area. On the map here, what you've got is the habitat management zones for the abyssal plains. And we use the abyssal plains because that's the best place to find the minerals. And the hatched area is where the minerals might be located on top of these HMZs. So what you do is you simply take that box and you try and fit it on top of the hatched area using your mind's eye. And you could see that the green, yellow, and red would all fit fairly comfortably on top of that hatched area. So what that's telling you is you've not gone and designed a simulation that couldn't even fit. It could fit. On this side here, we're actually looking at a second reality check. We're looking at the metals production case. So the International Energy Agency has released forecasts for how much cobalt is going to be used over the next 30 years, what matches what we're doing here. So we're quite lucky that we were able to access that. And they do different scenarios, a lower scenario, a more modest, a middle of the range scenario, and a higher scenario. And I won't go into the details of those. If you want to know more about that, read the report or reach out to us. This is for total cobalt demand, but the IEA have also done simulations, I should say, or scenarios, for recycling as well. So this is total, and this is what we call primary cobalt demand after recycling is taken into account. And this recycling doesn't exist all today, but it's forecast to maybe come online in the future. Anyway, the most important one to look at is the red one. That's our high case, our biggest area and our biggest amount of cobalt production. And when we look at the amount of cobalt it would produce, it shows that once recycling is taken into account, the mining in the Cook Islands would supply all the world's cobalt. Now, that's not very credible. That's a limited credibility, I guess you would say, okay? I guess it's theoretically possible, but it's not very practical because the world will take cobalt from other places as well. What that tells us is that our high production case, it just fits, and that's about the limit of what it could get. So it's not going to really get any bigger than the red line. And in the end, what the team chose to use in the cumulative impact assessment was the high case. For the other activities, we were really fortunate that we could get a lot of data from Global Fishing Watch. And what you're seeing here is fishing activity for the region. If it's a light colour, there's more activity, and if it's a bluer colour, there's less activity. Clearly, fishermen prefer to fish in international waters, less so inside exclusive economic zones, and that's, of course, because they've got to pay additional licence fees in the EEZ. And clearly, there's more fishing taking place in the north, effectively at the equator, and less as you go south. This is for longline fishing, and this is for the last 10 years, or from 2014 through to the end of 2023. And what it shows, this particular bar here shows a little bit of growth here at the beginning, probably more data becoming available, and then a fairly consistent rate of longline fishing. There's a little bit of a dip here in this year. That's probably because of COVID. This particular one underneath in green is for Pisaning. It's exactly the same as the one above. It shows that, of course, Pisaners really work in only the highest latitudes in the north. It shows that there's been a decline over the last 10 years. Presumably that's because of changes in policy by FFA and some of the countries concerned. This one in the pink here is not looking at fishing activity, but at vessel presence. And what it shows is for support vessels, these are like bunkers and reefers for fishing boats. It's showing that the development over time is like a combination of these two. This kind of data is really useful because what we can do with this data is we can download the data within the Cook Islands, the EEZ, and then we can overlay that with the area that might be mined by for minerals, okay? And then from that we can work out interaction probability, and that's what this chart is showing here. Again, this is probabilistic. And what it's saying is that for 80% of the likelihood, fishing vessels will only come close to mining vessels once every 6 months to every 2 years. So it's not going to happen every day or every month. Maybe once a year, once a 6 months, or maybe once every couple of years is what you should expect. Of course, it depends on where you work. If you work in the north, it'll be slightly more likely, but in a lot of the Cook Islands, fishing boats aren't that common.
In evaluation of the impacts of seabed minerals extraction on fishing, something to really consider is the kinds of food webs that are involved in the natural state of the environment. And this diagram here is the result of a recent study by Australian and New Zealand researchers for one of the contractors in international waters who are looking at seabed minerals development. The different parts of the web are shown through this diagram with arrows and other symbols showing which way material could move. What this diagram shows that the bulk of all material flow, the bulk of the food web, starts at the top of the water column towards the surface and then moves to the depths, not the other way around. The implication is that disturbance on the seabed is unlikely to cause impacts in the top of the water column, where, for example, fishing stocks are located. There are other kinds of impacts not considered in this diagram, the most significant of which is noise, because noise does transmit through the entire water column, although it does get quieter with distance. Another important aspect to consider is in terms of the severity of, say, for example, sediment lifted by plumes, either in the middle water column or at the base. And the first thing to bring in mind, of course, is the way it works with nodules, especially, is you extract the nodules from the muds, and some of the mud and some of the particulate matter is returned into the water column. And this is natural material. It's not tailings, for example, that have been processed with chemicals. And again, most of the sediment sinks to the seabed. This is a diagram on the right-hand side of the natural sediment load to illustrate the natural sediment load that's found in the atmosphere and in the oceans, the different sources and the different types of sediment that are found depending on things like the water depth and other chemical conditions in the oceans. And the primary direction is from the surface down to the seabed. So when people evaluate the effect, say, of a plume, it's got to be done against these natural background amounts. And the levels that scientists are talking about are really low. The water to the human eye would look completely clear. It's often within the thresholds for drinking water, but still we need to accurately understand what changes might be imparted into the water column by the activities.
We've done the same thing here now for cargo vessels. As you can see from this Global Fishing Watch map, it looks very different, and that's because cargo vessels go mostly between major ports in these narrow sea lanes, ones that are most efficient for them to use. And over the last 10 years, you can see there has been continual growth in cargo, and that's reflected in the world economy. If we go and look at our interaction probabilities now, for 80% of the probability, we're seeing that cargo vessel would meet a mining vessel maybe once every 5 to 30 years. So that's because there's a lot of places where cargo vessels hardly ever go. Now, it's not impossible, it is possible, I guess, that a seabed minerals extraction operation might start right in the middle of a sea lane, and if that's the case, you'd be at the tail end of this probability distribution. That's the end of the discussion now on the quantitative kind of the analysis. We're going to go quickly through the qualitative assessment of the other drivers before we come back to the results of the cumulative impact assessment. Starting with artisanal fishing was assessed in a couple of ways. The first thing is we looked at the DIPSA impacts from artisanal fishing, and you can see the outcomes are extremely low. That told us that the incremental accumulation of impacts from artisanal fishing on any seabed minerals activities would be minimal. But that doesn't even really matter too much, because artisanal fishing tends to happen within about 10 to 20 nautical miles of the islands, and our Marae Moana MPAs extend 50 nautical miles. That means there's no horizontal overlap between the two. And so that then says that any accumulation, again, should be zero or extremely low, say in the case of something like drifting debris or something like that. When we looked at the potential cumulative impacts for things like buckers and other passenger craft, we found that they're also expected to be minimal. Now, these yachts and other passenger vessels and buckers do travel throughout the exclusive economic zone. You can see from this Global Fishing Watch data that they're a bit different to the cargo vessels. So a lot of them are going from Bora Bora up to Swarara and Palmerston, for example, as well as we get a little bit of inter-island traffic within the Cooks itself. But the amount of impact that these operations produce is expected to be extremely low, and thus they would not have any material accumulation on top of that would happen from seabed minerals extraction. Tier 2 exploration activity was considered within the effects assessment. This chart speaks for itself that the expected effects have quite a low significance, so it was not added to the cumulative impact assessment for the seabed minerals. This one was a little bit trickier. This is about the support vessels that work for the seabed minerals sector. Now, within the seabed mining area itself, they were considered. The way that was done was that the exposure from the seabed mining extraction vessel was roughly doubled. Okay, it was assumed that at any one time, whilst there was a surface vessel working, there would be one of these three types of vessels alongside. Bulk carriers take the ore from the surface vessel to market. Supply vessels provide provisions and crew for changes and things like that, and a bunker vessel provides fuel. So we just assumed that there'd be one of those alongside at any one time, making roughly the same amount of impact. But one thing we didn't consider in that, of course, is the transit in and out of the mining area. So we did assess it semi-quantitatively, and it looked like it was going to be pretty minor or negligible, okay? And it was going to be really complicated to model. I mean, in the future, when this gets updated, it could be looked at again, perhaps when we have more accurate ideas of how or what scale this would happen at. The next thing we looked at was tourism, and tourism is really important for the Cook Islands, of course, but it's been suggested that if seabed minerals extraction started in the Cook Islands, it could have an impact on tourism. So this was done in a couple of ways. The first thing what we looked at was, would seabed mining vessels be visible to tourists? And the answer is effectively no. This is a particular cross-section. There's an atoll here underneath my picture, and that's the surface of the sea, and then this is the seabed. And there's two things you could consider. The first one is, how far would you have to go out from the island before you could even see the top of the mast of a seabed minerals extraction vessel? And the answer is you have to go over 30 nautical miles out, just because it would be below the horizon. And that's if the ship was right at the edge of the MPA. In fact, the ship would be more likely to be much further out from the MPA and well out of sight. The second thing to consider is, would the plume be visible to any tourists? And the answer is no. The reason is the work done to date shows that the plume is going to be restricted in space and it will be kept near the seabed. So you're not going to be able to see that either. That doesn't, of course, mean there won't be a perception issue. We have consulted with tourism on this particular issue, and I think we have agreed that if this perception problem arises, it could be dealt with through some kind of campaign. Last but not least is subsea cables. This is a map of the Manitoua cable. So it comes in from Pago Pago and goes through to Bora Bora, and it spuds off into Rarotonga and Aitutaki. So we put in a margin at SBMA, a buffer to make sure that it is protected from any activities, and today it doesn't even overlap with any of the exploration licenses shown here in brown. So we don't think there's any accumulation that needs to be considered in terms of submarine cables or interactions. This is now the answer for the cumulative impact assessment. Well done for hanging into here. This is for nodules, and this particular chart you've already seen. This is the results of the effects assessment. What we did was we took all of the different activities and we did DPSA assessments of those, and because they were all on the same template, we could add them together, accumulate them in effect. We did it in two different ways. The first way we did it was we took a single nodules operation and we accumulated it with other types of marine operations like fishing and so forth. So each of the pressures from the nodules operation had additional impacts where they accumulated with things from the other operations. What you can see there is the dots move around a little bit. Some of them rise up, some of them move to the right, i.e. for some of them the severity increases and for some of them the extent increases, but they're not massive changes. Nothing jumps out of the green into the yellow or let alone the red. Okay, the negligible to minor significance, none of those go up to moderate to severe, for example. There, the other way we accumulated it is we accumulated multiple nodule operations, and the case you're looking at here is the high ramp-up case, which is that red line I was talking about before, the one where we supply all the world's cobalt if that ever came to place. Here, the dots jump mostly to the right. The team didn't find any real increases in severity, but they did find significant increases in extent, and they move into this moderate to severe field. In fact, none of them really go past moderate if you look at the significance of the effects themselves. You can combine these two to get your final answer. So this is it. This is if you had as much nodule development as the market could handle, on top of ramped up fishing, ramped up cargo vessels, things like climate change. And the answer is it looks really similar to the multiple nodule operations. It's just a few of the dots do move slightly. And what that's telling us is that even if we had a lot of nodule development here in the Cook Islands, as much as the market could handle, we wouldn't go past moderate significance in terms of effects or impacts. This is what we did for the other types of mining. This is the crust and the muds. And again, the dots basically jump to the right-hand side slightly. So conclusions from the cumulative impact assessment. When we looked at all the different sectors or drivers, it found the two that really might accumulate are longline fishing and transiting cargo vessels. When we looked at the pressures that these and seabed minerals extraction could generate, the things that would accumulate were really noise. And that was the most likely one. And that's not a real surprise because that's the thing that would go a fair distance. When we finished the accumulation, nothing went beyond moderate. And the team said this is principally due to the fact that it's a big ocean out there. And so there's not that much interaction between any activity. The things like plumes and other minerals extraction impacts are assessed not to negatively interact with fisheries. That was looked at really carefully, and in the end, that's principally due to the spatial and vertical separation of these pressures. It's just things like plumes are going to be much deeper and away from any fisheries. Polymetallic nodules, minerals harvesting, was the thing that could accumulate the most. So if you want to accumulate impacts, the way to do it is to have more and more nodule operations, okay? But even when we went to our high case, where we'd meet all the world's demand of cobalt, we don't think that it'll ever get reached really, and that's what we considered in our effects assessment.
So just to recap, this is the end of the technical part of this background presentation. We've talked about the ecosystem-based management framework, the marine spatial assessment, the effects assessment, and just now the cumulative impact assessment. The results are encouraging, but there's still a lot more work clearly needed before any further development could happen offshore. Now we're going to the last section, the one about the Regional Environmental Management Plan, and that's where we want to know what you think.
So thank you very much for sticking with us through the cumulative impact assessment. We're now getting to the last of the sub-programs, and this is the one we're actually doing today. This is our Regional Environmental Management Plan. Certainly, you've done well getting through the presentation to date, but what we're looking for now is some feedback. And the way you will do that is through a survey. The two ways we can do it virtually is you can scan this QR code, that'll take it to you, or you can type this particular URL in your browser, or go to the SBMA website and look for the REMP survey link. And don't worry again, if you've got friends or family who haven't seen the video or come to any of our meetings, we're going to be running this through to July 2025, and this online version should be available. And the last comment, of course, is the survey. When we designed the survey, we used Orca Consulting to help us do it properly, and they made sure we worked in line with this Guide to Good Survey design that they use in New Zealand. The survey is going to be followed by a workshop. It's likely to be in July here in Rarotonga, or maybe in August. It's going to be a hybrid, so if you want to, you can dial in if you can't make it. We're going to present the results of this survey, and we're going to give some ideas on how we might change our policies. And we're going to record what everybody thinks and try and accommodate everything that we're doing, either today or in the future. So thank you very much for watching this, and we'd really like your contribution, please, if you could, in this survey.
Mendaki Mata!